Hi everyone, welcome to the Tech Talk of Demcon. Today we have Tjerk Belsma, CTO of Demcon Johan Sports, David van der Meijden, Data Scientist, and Shiona Sequeira, Software Engineer at Demcon. They're going to talk about challenges in creating a sports tracker for health and performance. Enjoy the Tech Talk. Tjerk, the floor is yours.
Thank you, Marleen. So today we will talk about the challenges in creating a sports tracker for health and performance. A sports tracker from Johan Sports. As Johan Sports, our mission is to help sports teams to perform at their best in a healthy way. Demcon Johan Sports is part of Demcon. That means that we can use the technical knowledge inside of Demcon. We actually even use Demcon production for the production of our trackers. And we have a flexible engineering team because we can involve also the engineers from Demcon in the projects for Johan Sports. Who do we serve as Johan Sports? Well, we have teams around 28 different countries. We have 150 plus teams that are spread out over 28 different countries. We focus typically at team sport, outdoor, football, hockey, rugby, and we look into physiotherapy for players, athletes that are injured, that are recovering from an injury. We need systems that have accurate sensing. This is needed because we work with team sports outdoor that have a lot of explosive actions. So, for example, sprints and changing directions, as you can see in football and hockey. And now David will explain you why we need these systems in the field.
Yes, performance is tracked daily by the analyst and coach of the teams. But what is the performance and health? They see daily the exertion and the external load and internal load of the players. This means the external load is based on the GPS and IMU values, and the internal load, they look at the heart rate of the players during the sessions. These values can be looked at during the session in our live graph or after the session in our web app. They see these values and they can compare those versus the set targets. They can compare teammates between each others. They can compare the players to themselves in different sessions. And they use these all to assess the fitness, to plan schemes, and to prepare for the most important day of the week, the match day. I will give a few examples how these are shown. For instance, in the live graph, the general overview is a table where all the players can be seen. In this example, we see the heart rate, and the current value of the heart rate, the current speed during the session, and for instance, values such as the total distance and the sprint meters. You can already see that we can compare those to set targets. In the web app, we can also compare the session afterwards. For instance, by evaluating the players versus each other, so between teammates, or afterwards versus between sessions between the same player. In this example, we see two players compared to each other. You can see the values for total distance, number of sprints, or the average heart rate. To dive more into the session itself, we can also view the player during the session. In this time graph, we see the heart rate, the sprint, the total distance during the session. So you can see the exertion, internal load, and external load all over time. An analyst can also dive more into one specific side of the session to see, for instance, an exercise or one specific moment. These are all used to assess the fitness and performance and health of the players. But how are these values gathered? With the Johan Sports system, we use trackers. These trackers are worn by the players on their front side or on the back side. They can connect to the live app. This can be a personal live app on the phone of the player, for instance, but generally they are used to analyze in the live app by the analyst. This is generally a tablet. But as a tablet only can connect to a few Bluetooth sources, and doesn't have a Bluetooth connection which has enough range to cover the whole football field, we have a smart hub. The smart hub is not only the charging station for the trackers, but can also be a hub between the trackers and the live hub. The smart hub can connect to up to 24 trackers and then sends data to the live hub. Next to it has a long-range Bluetooth implemented in the smart hub, so it can cover the whole football field or whole sports field, and thus there is no connection loss. The data is then sent to the web app, and we can analyze afterwards how the more analysis based on the web app. Tjerk will now tell more about how this system is developed.
Thanks, David. Yeah, so now we heard what the coaches and analysts are doing with the system. We will talk about the production process for such a tracker. As you know, typically such a life cycle starts with designing a concept, having a design, prototype, a stable product, and going into series productions. In the beginning, what you see is that for the concept phase, typically mechanical and electrical engineers are involved. Then for the design phase, well, firmware and front-end specialists also need to be involved because we need to have some software running on the tracker and it needs to interface with the tablet, and that's the front-end development. When you get a stable product, also backend has to be involved because you have to store the data from the tracker somewhere in the cloud. And then when you go to series, the data science, as discussed by David and will be discussed in detail by David, is becoming more important because the data science means that we're going to add parameters to the tracker, so insights to the coaches and analysts. Today we want to dive into a few topics with you. We want to tell you about the wireless power charging issue that we found and solved early on in the production and the prototype phase. The validation and innovation of algorithms, discussed by David, and flexible firmware, which will be later on discussed by Shiona. The wireless power charging issue. During the prototype phase, we discovered that our smart hub was using more than 80 watts to charge the trackers. This was an issue because using more than 80 watts requires, well, special measures in the system. For example, a fire enclosure, we need to get rid of the heat. We didn't want that. So what we saw was that charging was only 35% efficient. So we were losing a lot of energy in the system. We wanted to get rid of this issue. So we investigated the potential root causes. First of all, we looked at how the tracker was charging. It was using too much power to charge. And second of all, we looked at why the efficiency of the wireless charging was so low. In the tracker, we found a graph that specified the efficiency of charging in the tracker. It had a kind of behavior that the faster you charge, the more efficient you are. However, if we charge fast, we require more power from the smart hub, which was not possible. So we had to find a sweet spot. And the sweet spot was around 70% efficiency, which was 240 milliamps. This was still acceptable in the amount of heat that was produced in the tracker during charging, and the amount of power requested from the smart hub. Then, understanding the wireless power charging, we investigated the coils. We saw that the transmission and reception coils in the smart hub and tracker were performing according to spec. So they were using 6.5 microhenry. Next to that, we looked at the distance and alignment of the tracker on the coil. We saw that it mattered a lot. So if you place a tracker with the housing in between immediately on the charging coil, you have an efficiency of 77%. However, already when you add a 1 millimeter spacer, you lose 8% efficiency. You go to 69. Therefore, what we did was we tried to minimize the distance between the charging coils, as you see in the left bottom of the screen, and the tracker. So we reduced it from 3.7 millimeters to 2.2 millimeters by having a recess in the hub plate on the bottom in which the charging coils of the smart hub exactly fit. So the coil of the smart hub is aligned exactly to the bottom of the tracker, and it is very close to the tracker. And thereby the efficiency went from 45% to 54%, such that our smart hub charging issue was solved. David, can you now explain us how the parameters are used in Demcon Johan Sports?
We now have a working tracker, but how do we know that the data received from the tracker is also correct? At Demcon Johan Sports, we often compare our system to the golden standard in the field. For instance, for the GPS, we can compare our system to the LPM system. When comparing these, we try to optimize afterwards our variables, our values from the sensors to be as close to these golden standards. We do this by designing filters or other adaptations for the GPS, IMU, and ECG data. This will result in firmware improvements and thus the best available data. Next to that, we also have a few additions in usability. Teams and analysts often request new ways to have insights into the data. They want to have new graphs or new types of analysis. Besides that, we also look into the latest scientific research and new analyzation techniques, such as machine learning and AI. We try to update our visualization set and thus improve our data, extend the data intelligence, and update the graph for both the live app and the web app. Besides, we also try to innovate our new parameters. Based on scientific research, often new things are discovered how we can measure the best performance and health. Next to teams also requesting, of course, new ways to analyze. For instance, I listed a few things I have been working on the last few months, such as heart rate recovery, sprint recognition, and heart rate variability. I will highlight heart rate recovery to let's see the process on how we are doing this. Heart rate recovery is an important value to assess the fitness, performance, and health of a player. But the raw heart rate value we get from the tracker isn't often quite good enough. Normally it's quite noisy and it contains a few outliers due to the movement of the player. So we have to remove these outliers and filter the value more. We do this by developing a filter based on the mean and median. This results in a heart rate which can be analyzed. We already see that this value has a lot of new ways to assess the information, and we see already the recovery and the exertion based during the session. For instance, during an interval short run test. These tests can be used to assess the fitness of the player. This is one of the typical tests, and the analyst normally looks into the recovery during such a test. For instance, during the test in the little peaks, or after the test with a large recovery. During such a test, they often look to the 30 seconds, 50 seconds, and 60 seconds recovery after these tests and can compare those between the player to different sessions. In this heart rate recovery, we will make this as easy as possible for the analyst by making it clickable, so you see these values during the session immediately to assess the fitness of the player, but also, of course, afterwards in the web app. These new innovations always have to be implemented into the firmware, and Siona will talk more about that part.
Thank you. Yeah, so we get all of the firmware algorithms from David, but in order to make sure that what we implement is not a duplicate every time, we need to structure it properly. And that's where the entire architecture design comes into place. So for the Smart Hub and the tracker, we try to make sure that we write a single piece of code once. So all the common code that you find, if you look at the layered software design, is at the bottom of the design image that you see. We then need to implement each of the sensors that is hardware specific. And that comes under the driver, and everything that we want with respect to the session files, when we want to start a session, when we want to stop a session, comes under the application. So when we were designing and choosing the required hardware and software parts, we tried to make common parts, including the microcontroller that we use and the Bluetooth chip. In order to test what we have with respect to what David gives us, we have a proper test framework in place, which when something is different, it will pop out an error. So the test framework that we have right now is for accelerations, distance, and heart rate. So in order to keep improving and making sure that all our customers in the field are very happy and satisfied with our system, we need to increase our functionality and further our reliability as well. So in order to do this, we have established thorough logging, which you can see on the picture on the right, wherein we get information on how the tracker is doing, when it retrieves data from a certain sensor, when it needs to spit out data to some other external source. And we also try to improve and optimize other sensors. So we've tuned our Bluetooth to work with not only long range, but also with short range, so for downloading of data from the tracker. We've improved GNSS settings so that no player's workout is actually lost. And we're trying to improve the battery life further so that they do not have to keep charging their tracker every time. And now comes the most important one, is that we want to prevent any crashes from happening in the field. And we've come up with 3 steps so far that can help us mitigate such an issue. And the first one is that we want to reset the storage, so that if we fail while writing something to the flash, we can reset it and it keeps working and we do not lose data. We reset the fuel gauge, so if we read out something wrong, we will automatically adjust it. And we resend the start session, so it's like a prevention scheme, so when a message is lost, we will make sure that we still send it again so a session keeps going on. I would like to pass on the word to Jack for the final words.
Thanks, Fiona. We heard a lot of things today. So first of all, we discussed the charging issue with the Smart Hub, where we use too much power. We learned that if we align the tracker and the Smart Hub coils very well, and we have a small distance between them, we have high enough efficiency to charge with, well, below the 80 watts. Next, David told us about the validation of the tracker in the field against golden standards, which is needed to get, well, an accurate system, and also about additional parameters, for example, heart rate recovery, that are a lot of value to our customers. Finally, Fiona told us about the stable firmware for the sports tracker, which is essential for a good sports tracker in the field. Thank you for watching. I hope you enjoyed the Tech Talk about the challenges in creating a sports tracker for health and performance.